this .env. You must not push this .env file to node. And most of the times, you shouldn't push this .env. So this file is basically for project secrets like API keys and the rest of those. So this stays in your .gitignore. And I think we don't have a gitignore file in this project, but you always need to include your .env in your gitignore so that you will not mistakenly push it there. So that's really all that you don't really need to push. Right? Every other thing needs to be in version control. So
okay, I understand.
Yeah. So Gideon, I think I'm seeing this name for the first time. Gideon. Do you have any questions?
No, I think the only question I have is if this class are the classes recorded so that I can go and catch up, because I've fallen way behind. I attended one class many weeks ago, and
okay, sorry for putting the class is on YouTube, so you can always go to YouTube to catch up.
Okay. So sorry, how do I access?
Okay, you will look for KodeCamp on YouTube, like KodeCamp.
Okay.
Yeah.
All right.
So when you get to the KodeCamp page, you will see the lectures there.
Okay, no problem. Thank you.
Okay, so we are going to start from where we stopped in the last class. The last class was all about authentication. We completed registration and we looked at authentication. So we are going to continue. Now, before we start, there is one error we had in the last class, and it concerned this. If you can see line 81 and 82, I commented it out. Right, I was trying to append the expiration date of our JWT token to the token itself, right? And we're having error. So we are going to work on fixing that in this class. To do that, I want to actually replicate this error for you to see. All right, so let me start this way. All right. Now, if we try to log in as it is, if we try to log in, if we click this, you can see we have an internal server error, and the error actually originates at, let us scroll up. Yeah, the error originates at line 34 in login. As the routers./or.py, line 84. Yeah, so here is where we have the error, jwt.encode, and we passing what we want to encode the secret key and the algorithm. So for some reason we're having errors there. And if you scroll down the error log, we'll see a type error that object of type datetime is not JSON serializable. Yeah, this is the issue we were having in the last class. So the main problem is we are trying to pass in a datetime object to our JWT token. All right. If you see at line 81, we created an expire, and this expire variable is equal to the current time, that's the time from now, and we are using UTC time zone. Then we want it to expire in 30 days from now. Okay, so that's a datetime object, and we are passing this datetime object to the dictionary we want to encode. All right. Now, Unfortunately, you cannot serialize a datetime object to JSON. Hence the error we're having here. So to fix this error, it's very simple. We simply convert these datetime objects to string. So this is how you do it. You simply, if you want to convert something to a string, you simply cast it, all right? You wrap it with string. If you want to convert to an int, you simply wrap it with int. So that's how we do that conversion in Python. So wrapping this with a string, we simply convert that datetime object to a string object. And with this, we shouldn't have that error again. So let's try. Okay, one more thing. Okay, I won't comment this. Okay, so if we test this, we should see that it now works. It now works. We now have a token key attached to the response, and this is our JADE waiting. So please, do we have any question on this before we move to this?
No question from me so far.
Okay. It's all right. So the next thing we are going to do is to look at profiles, right? So far, users are able to create accounts and users are able to log in. Right. So we are going to look at how we can just basically get the users to update and delete their accounts. If I want to update my details or if I want to delete accounts, so that's what we're going to do in today's class. And before we actually get to that, I would love to set up the test environment. I think before we get a version test, and we did this a couple of classes ago. So I want to just basically set up the environment for this test so that when we get an endpoint, instead of testing manually, we can just easily write the unit test for it. Move on to something else. So I want all my tests to be in a folder called test. So I'll create a folder and I'll call that test. So with that, we have this folder. Now, we are going to create a new file called conf test. It's a short form for configure test. And we will use it to, should I say, create our tests, like the test configurations, right? All the configurations we need to run a test will be housed in that particular file. I also want to create an init file to convert this to package. So this particular module we need PyTest. So I'm going to import PyTest. And we also need Redis. So I'm for Redis as well. We also need fast API. So I import fast API. We're also going to make use of lifespan manager from this particular package. From this JLS one, we actually use it to inject a particular object into the application startup or shutdown event. So I'm going to import lifespan manager from ASGI from AGLS1. I'm going to import lifespan manager. Then we want a request client that we'll be using to send a request. And for that, we are going to use HTTPS, the library HTTPS. This is it, this particular library HTTPS. So we are going to import some clients from HTTPS. So clients. Now, the next thing we are going to make use of is register tutorials, and register tutorials is this particular. Let me show you. If you come to database, file, you will see this. Now you see this. So in some cases, like when you are running tests, in some situations, right, we run tests with a separate database. Right? But that's not the case in this particular project. I want to use my main database for tests. Okay. So in such cases, you may not need to specify a function that you'll be using to initialize the database. Right? In this particular case, I'm just going to include it in case you come across a situation in which it is used. So I'm simply going to copy and paste that. Okay. Now we also need to get an instance of our application. So with that, we can import get application from server. Then we need the database URL as well. Okay. So I'm creating a database URL variable here. So instead of like constructing the URL in each file that I need it, I can simply import from this config. So we should just start here from database URL. From config, we will import database URL. All right. So now the first thing we're going to do is to create an instance of our application for our test environment, and we're going to do that now. We'll define an application called app that will return, that has return objects called fast API. And it simply gets a reference to application. Then we instantiate the application. Simply return the Now we want this to be a fixture. We want this to be a PyText fixture that we want a model. So let me pause for questions. Do you have any question concerning what we just done, especially this PyText fixture? I was expecting a question on that.
Okay. Though I'm still trying to understand this, but no question from my end. I don't know for others.
Okay, give me a minute.
So again, this what we are doing now, we are trying to run tests now on the code.
Yeah.
On the whole code.
Yeah, we are creating a test, like a test structure that we'll be using to run the test. So by these fixtures, like what you are seeing here, like line 12, maybe I'll not be able to give you a comprehensive explanation of that, but you can read more about it. They are, should I say, they are functions that you want to execute before each test. Take for example, let's say you have a test that let's say you want to test login, right? And you know that before a user can log in, the user needs to have an account, right? So it won't really make sense to say, okay, because I want to test login, you go and maybe send a request to the register endpoint and all of that. Though it's possible, you can do that very well. But doing that for every single input you want to test will be too cumbersome. That's where fixtures come in. You can write the code that you want to execute before each particular test runs. Okay, so you simply write the code. For example, this number 13, line 13, we define a function called app that we want to simply get a reference to the application. Then, when you've written the code that you want to execute, you now decorate it as a fixture. Okay, and you then specify the scope. This scope like specifies how often you want this particular code to run, right? So we want this code to run for each test module. Let's say we have a test module called maybe this test registration.py, then test login.py. These are individual modules on its own. So when you decorate a fixture with a scope of module, it will be executed once for any test module we have. Then we have some scopes of class, meaning this fixture will be executed for each test class. Then we have scopes of session, we have scopes of functions. So the basic thing you need to take away here is that these fixtures are code that you want to execute for each test. Right, so that's just it. I hope you understand.
Yes.
Okay. Now we have taken an instance of the application. Now, the next thing we want to do is to create a client. the request client will be using. I don't want to be creating this request client for each test I want to write. So I will just extract it to fixture, and we'll then use this fixture for the test we need to send requests for. So this will be an async application. This will be an async function. So async function, and we'll call this client. And clients will take an app. We'll take this particular app we created here, and this app is of type fast API. Then the return object is an async client. So to actually do this, we are going to let me do a little bit copy and pasting. I'm going to have something like this. Sorry, was spelling. Okay, so what this piece of code from line 19 to 25 does is that we are basically injecting this async client right to the application. Whenever we start this test session, we want to simply inject this client to the application so that it is available for us. That's basically what we're doing. Async with lifespan on Ninja, then we pass in the app. Then async with async client. Then async client takes an instance of the app. It takes a base URL, then it takes the header. What kind of request you want to send? You want to send JSON request. So that's this. Then when you're done, you yield the client. So that is that for the client. Then the next thing we're going to do is we need to initialize the DB. And like I said earlier, this may not be necessary if you are using the same database you are using for the main project. But I'm still going to include it here for reference purposes. Okay. So at 939, we have a function called initDB, an asynchronous function that takes a reference to the application and doesn't return anything. That's why we have the return value. Then this function basically grabs an instance to just grabs the reference to the database. Okay. Register purpose, like we saw here, it's basically this. It's basically what we have here. So it takes the app, then it takes the database URL, and it's equal to database URL specified at config. Then you are going to tell it where the models, your database models are, and our database models are the models, right? Our models package, and this is it. This models is this. Then we also pass it array.models. Now, do you want to generate schemas? Yes, we want it to generate schemas. What this generate schemas means is that if you don't have the tables, if these models you created doesn't have tables in the DB, do you want it to create these tables? So we want it to create the tables. So that's that. Now, the next thing we are going to do is we need a reference to the event loop. We need a reference to the event loop so that our DB connection can go successfully. So to do that, we are going to make use of a Python package called Essential. So we import assumption. All right. So now we have another part of this fixture here that has a scope of session. What the scope of session means is that this particular function called event loop should only execute once for this test session, right? When we make tests, okay, it should only execute once. We don't want it to execute for maybe each module, each class, or anything. It should just execute once. That's why we have a scope of session. Then at line 49, we have that loop is equal to essential. This is the form, and this is the library imported. There's at the first one. So you can see line 1 is imported essential. So we call get event loop policy from essential, and we then get an event loop yield the loop. And when each test session is done, we close the loop at line 51. That's it. Okay, please, any question so far? Is any question on this so far? My cannot change. Any question? All right, none. So the next thing we're going to do is to write a fixture. Is to build a fixture that will be in charge of cleaning the database. I want to actually clean a database for each test class. Right? When I execute a test class, I don't want the content of the DB to be carried along to the next test class. So I want this to be clear. So to do that, I'm going to define a function for clean database. Then within this function, we are going to first import the schemas we want to clean. Right? So far we have a model for tweets, we have a model for likes, then we have a model for comment and media. So I'm going to import those. Then I think that's all from here. But now from users, we have user and picture. So I want this claim as well. All right, so what we're going to do is to simply claim the schemas. Right? So with fast API, if you want to delete a particular query set, you call delete on it. Now we want to delete all the users in the DB for each particular test, for each particular test class. So we simply await. We then call users or all to get all the users within the database, and then we call delete to simply delete them. Now let me specify the fixture. I want this to be executed per class, and I want this to be executed without me calling it. That's the use for how to use this quotation. The next thing I want is to play pictures, tweet, like media, and comments. So with this, we now have the code we can then use to create the database for each test lab. And the next thing is don't forget I'm working with two databases here. The first one is Postgres. The second one is Redis. So I also want this Redis to be played for each test session. And we want this to declare the function. So for that, we are going to remove this scope. When the scope is not there, this particular feature is executed for each test function. So I'll call this function clean release. And we are going to get an instance of all this. And our host is equal to Redis. Please, this host is basically the name of the service that stores our Redis database. And if you look at our local compose config, you will see at line 30 that this particular service is called Redis. That's why we're using that as a host. Now, Redis port is at 67, 63, 79. That's our port. Now, to clear the entire database, we simply call flush all and that will be. So with this, if you look at this, you see that it deletes all keys in all databases on the current host. So it basically clears the database on this particular host. So I believe that's all for the config. We've created fixtures to get an instance of the application and to instantiate our request clients. We've also created a fixture to handle initialization of the database. Then there's also another one to get event loop. Yeah, there's now one to get the event loop, and we have one to clean the database and also to clean Redis. Okay, so do you have any question on this?
Okay, so this you fix the clean database function created is it like from, I don't know if I understand it correctly. Let's say since we are testing, you'll be running the test multiple times. So is it that like when you want to start the test, you clean the database to make sure there's nothing there before you run the test?
Yes, we want to clean DB for each test instance. Right, I don't want a situation in which I run a test and we still have remnants of the objects that were created that test, going on to the next test. So that's why we're creating this clean database fixture. This particular code will be executed at the end of each test class. So when done with this test class, it will like wipe the database, clean everything, and then we'll go to the next test class and execute it. And when we're done, we clean everything. And it just goes like that.
Okay. Then the Redis now, this clean Redis now, is it what's the difference? Because it also looks like it cleans, it's meant to also clean database or something. What's the difference?
Okay. If you look at our Docker compose, you see that we have two databases there. We have the main database, which is Postgres, which we're using that to store most of our data. Then we have an in-memory database as Kode, and we use this to store the data that we want to like extract very quickly. With things like we used it in the last class. Let me go to yeah, let me go to I think at register, yeah, I think at register, if you look at line 35, we executed this function, OTP manager of create OTP. That's what we call it is like the account verification token, right? So this account verification token is stored on Reddit. So let's go to the OTP manager. Yeah. If you look at the create OTP, you see that when this OTP is generated, it is then stored on our Redis database at line 28. Okay, it's just like an in-memory database. The data is stored in memory and it is persisted in the file system as well. But most of the operations is done in memory. So that's what we are clearing at line 69. We don't want this data that is stored to carry down, like to be carried down for each test class, for each test function. Hence the need for like cleaning this.
Okay,
So I hope
okay,
you
I
understand,
understand.
right?
Yeah.
Okay. So now let's test if this actually works. So I'll create a test class, then I'm going to write a sample test. So just basically check if all we have is correct. Then we're going to import PyTest. We're going to import PyTest. Then we're going to import FastAPI from FastAPI. Then we also need the HTTPS .async client for so from HTTPS sync. Right now, since we are going to run a synchronous test, okay, we need to define PyTest mark. PyTest mark essential. So you may be wondering why we need this. If you are running a synchronous test, that's test when your test function is an async function, right? You need to like tell PyTest that this test is going to run as an async test, and if you don't do that, it will be you will have some errors. Right? PyTest will not be able to actually execute this test correctly. That's why we need admin 6. So I'm going to quickly check this to just check if all we have is correct. Now we'll pass that. Now text the first argument itself and text map. Listen, this app is the fixture we created here. We created a fixture at line 17, right at line 17 of context 5. So that's the fixture we are calling here. Now the next thing we are going to get is our client. Okay, we don't need the client anymore because we're not sending any request. So let us asset that. Let us asset that one is equal to 1, and let me create a second check test. Let's call this check test 2, and it's going to asset that 1 is not equal to 2. Now let us run this test and see if what we did is correct, just in case you have any errors. Alright. Okay. I'm trying to open the test command here, so use that to run the test.
Okay.
All these tests. Docker compose, Docker compose on auth. Okay, we don't have a service called auth. Our service is called Twitter. So we want it to run Twitter, then go into Twitter and execute Python and string PyTest. And we want details and we don't want anyone. So let us run that command and see what happens. There's an error. Now, why is the error? Credential exceptions config error, default connection from the class and the user cannot demand. Okay. Connecting to this exception. Connecting to this. Okay. So we have an error here. Let's identify the error. And let's do it this way. I'm going to import everything language. Then we just copy and paste this. Let's try to do it. Default connection for class models with user community. Why are you having that error?
Okay, maybe let's check that users, that models file that is mentioned.
Okay. Let's see. Okay. Let's checking something. Picture. Okay. I'm getting it. All right. This this error is a little bit strange. We'll try debugging it here, but if it takes too much time, we'll pause it till next class so that we can move into something else. And in next, yeah, by the next class we'll fix that. But let me try one last trick, and if it still doesn't work, we'll resolve it in the next class. So let me use this instead. Database URL is equal to this. Then let me change this to Postgres. Instead. It's a server, not this port. Because I'm going to remove all of this, and I'll import from the database URL. Then I will replace this long string with the database URL. So let's try this. If it doesn't work, we will fix this in the next class. Okay, so we still have that issue. We are going to fix this in the next class. To save time, I don't want to. We don't have too much time. I don't want to waste it all, debugging this. So by tomorrow we'll fix it. All right, so that's that for the test setup. All right, that's all for the test setup. we now have some of the we now have some of the models that we now have some of the functions that will execute that will need to actually run our tests. Okay. So the next thing now is we are going to build endpoints that we'll be using to update and delete our account. Well, let's say a user that has an account on our server should be able to update and delete the account. So to do that, I'll create a new module that is called users.add, and we are going to import from fast API something that's called a class that's called API router. Now, just like we did in our last classes for what we are going to instantiate that router. We're going to instantiate it. So that is that. And I want to call this, I want the prefix in this case to be user. Then we are going to have an endpoint for update account, which will accept a post request. And it shouldn't be a post request, actually, it should be a post request. And I want it to return user public. Right, so we are going to import this user public from library.users.register. Library.schema section. Schemas.register. I want to import user public. Okay. Now, I want to create a data schema for this update operation, right? And I want to call this schema user update. So we go to library.schemas. I'll create a new module called users.py. Then within this module, I'll create this user update class that will handle all the data we need to, that will structure the data we need to actually handle user updates. Then we can import it here. Updates. Yeah, that's that. Then we need to register this router in our server. That's our root server. So we import from routers.user import router as users router. Then we're going to include that router so that it will be discoverable by our application. Right, that's that. So with this, all the endpoints that we create in this particular module should be available from our application. I think let me pause here for questions. Do we have any questions on this?
Okay, for me, no questions so far. No.
Okay. So Mike, is any question? Mike, any question?
He'll probably send it in the chat. He said he's in a noisy place.
Okay, it's a nice. Okay, okay, it's fine. All right. So that is that. That is that. So now we want to, actually, when the user wants to update his or her account, right, you actually need to be logged in before you can update your account, right? In a normal app, you should be logged in before you can update your account. So I actually want to, write the utility code that will, check the requests that come in, and it will check if this request, if this request has this JWT token attached, and if this token is valid. Right, that's what you want to do now. This token that was returned during login, right? So actually authenticate a request, the client needs to attach this token to each other. So we want to actually check. We want to actually check this token. All right. We want to check if this if the request coming in have this token attached, and if it is a valid token. So to do that, I am going to create I'm going to create another folder called dependencies. Create a folder called dependencies, and we'll create a file called code.py. Then we'll do a little copy and paste to save time. Yeah? Import. So we're going to import this. We're going to import OAuth2 password here from Fast API to security, and we're also going to import security scopes from the same from that same part, that's Fast API to security. Then we're going to instantiate the OAuth2 password bearer class, and this class takes in the token URL, and our token URL is port login. Then this class also takes in the scopes. Right? We are not really going to make use of these scopes in this particular. Okay, for now, we're not going to make use of it. It is useful for permissions. Okay, take for example, you have an app with a lot of endpoints that let's say this endpoint is for this category of users, and this endpoint is for this category of users. Right? You don't want maybe users from one category accessing the endpoints in another category. That's what we make use of scopes. Right? At this stage, we're not going to make use of it. Maybe when we get to the admin section, we will make use of it there. So for now, you can safely ignore the scopes. So we are going to define a function on a single function called getCurrentUser, and it has security scopes of that security scopes. That's this security scopes we imported. Then it also has token string, which depends on O2 scheme. So we are going to actually import this from fast API. Fast API import depends. And this depends is used to, like, if you want to basically execute some arbitrary code within your endpoint, you can make that code dependent. Okay, you can make your endpoint code dependent on that particular code. So that's where this depends comes in. Now the next thing we are going to do is that we are going to extract this token. We are going to extract this token, and we'll do this. We're going to wrap this in a try block in case there's an error. So from Juicy, import JWT. So JWT dot decode. Right, we want to decode this token. This is the token that is attached to the header. So we want to decode it, and to decode it, we need a secret key and the algorithm. So we're going to import that from our config. I think our let's check. Let's code algorithm. So we don't have JWT algorithm. So we need to decode the token. And this decode token takes in the token, then takes in the secret key, and then finally it takes in the algorithm. So this is it. All right, so let me recap what we're doing here. Okay, so when a user gets this JWT token, all right, like in this example, take this example, we okay, take this example, we logged in and we received this token, right? So now to actually authenticate the request, you attach this token to your request header. Yeah, you attach this token to your request header. So you go to your header and you put in your token there, and your token should be of type bearer since it is a security token. Okay, no, it will be here. Sorry. Let me copy this. Let me copy this. For some reason, I cannot paste anything. I don't know. But I can type. I can't paste. So how this works is that you simply get your token and then put it here, or you attach it to your header with the key of authorization, then the value of bearer, then after bearer you keep a space and then your token, right? Your token will be there. So that's how you authenticate most requests. Okay. Now, when a request comes in to our endpoint, this get current user will be activated. All right. Now, you can see this token, which depends on who or to scheme. This goes under the hood and it goes to the header of the application. Okay, it goes to the header of the request and it looks for an authorization header. Then it takes this value. All right, it will take this value of your token and it will store that value here at token for us to access within our code. So I hope you understand that now.
Yes, I understand it.
Okay. So with that, we have access to that token without actually having to check the header ourselves. The code does it for us. Now we can, after getting this token, the user can maybe attach anything. Okay, a user can attach anything. So we need to actually verify that this is the token that we issued on login. Okay, with that, we make use of this decode. Okay, make use of this decode, derivative of the code, then passing our token, then passing the security and the algorithm. So if this token is our token, it will be decoded for us, and we are going to have a payload that's an object that is equal to these things that we encoded into the token. Don't forget that we encoded the user ID, then we also encoded the expire. Okay, so we are going to get those in this particular this thing. Give me a minute. So, okay. So the next thing we're going to do is to extract the data that we encoded into this token. All right, they are now available in payload. So we need to remind ourselves what we encoded. We don't forget to encoded the user ID. Then we also encoded the expire. So we need to extract that. So our user ID will be equal to payload for get user ID. Now the next thing we need to get is our expire. So to do that, our expire will be equal to this payload dot get expire. Right. Now the next thing we are going to do is to check if this user ID and expire exists, and if they don't exist, we will raise an exception. Okay, let us define that exception here. I'll call this credential exception. Okay, let me call this port exception. Port exception, that's authentication exception, and it will be equal to HTTP exception, which we will need to import from class API. And it should have a status code, of 401 or let us define the full status. Status of 401 status of HTTP 401 unauthorized. We are basically telling the user that, hey, you are unauthorized. Now we want to pass in the detail of your port token is invalid. So now if user ID and okay is known or expire is known, we want to raise that exception we just created. We want to raise all the exception. So what this does is that at line 25, it will decode the token, right? Then after decoding the token, it will then extract the user ID and it will extract the expire keyword. And if any of this is known, that's if any of this is unavailable, we want our code to raise an exception on that point. Now, the next thing is if there's an error in the process. Let's say we have a JWT error. To get that, we can import JWT error from JSON. JWT error. Then if we have that error, we also want to instead of passing, we want to also raise the exception. Raise what exception? So please, we are going to have this error if a user submitted an invalid token. Maybe a random string that is not really the JWT token, or maybe a token that we didn't encode. Okay, in such situations, our application will raise an exception of type JWT error. And in such situations, we want to like tell the user that hey, the token you submitted is invalid. Okay. Good. Another thing I want to do is I want to encode this. I want to pass in this data to our token pedantic system schema. So if we go to auth, you will see. Is it here? Let's look at this now. Okay, please give me a minute. The JWT schema, and that's what I'm looking for. Good. So we now want to pass in the data to this JWT schema so that it is now easily easily available for us. I'm going to import that JWT schema now from library.schemas.auth import JWT schema. Then I want to create a variable called token data is equal to JWT schema, and our user ID should be equal to this user ID we got there, and our expire should be equal to the expire we extracted from that token. So that's the first. So now there could be situations in which we don't have the right kind of data that we expect, and in such situations it should raise Pydantic should give us an error, and the error will be validation error. So we want to also check for these validation errors, and if we have that, so the same exception should be raised. Validation error. So we will then update this except, instead of except JWT error alone, we want to also check for validation error. In the case of validation error, we also want to raise an odd exception. Wow, that was long. That was long. Please, let me pause for questions. Do we have any question on that?
No question. I know you are just trying to, handle any errors. Just take care of any errors that might occur when we're trying to authenticate. So no error. So if I'm correct now, what we're trying to set up is let's say, is it for someone that wants to log in, or this should be for someone that wants to log in now? Like
No. We want to decorate endpoints that we want a user to be authenticated. Let's say, there are some endpoints that we want the user to be authenticated before the user can do anything with that endpoint. And an example is update profile. This endpoint, update. Oh, sorry, this should be update, not register. You can't really update your account without being logged in, right? So that's where we are going to make use of this get current user. We are going to pass it in as a dependency at that endpoint, so that when the user is sending request, the user will need to attach a request token, and we are going to validate this token. If this token is accurate, then return the user that has that token. So that's the logic we are trying to create at this particular point.
Okay, good.
Yeah. Okay. So now what we've done so far is we have decoded the token, we have extracted the user ID, we've looked at the expire and all of that. And if the code should pass the stage, it means that the token is valid. Number one, the user ID exists in that token, and the expire also exists in that token. The next thing we want to do is we want to check the expiration. Okay. Don't forget that we have this expire key, which specifies the point in the future where this token will no longer be valid, where this token should expire. We shouldn't make use of it anymore. So now we want to actually check for that expiration. All right, just including that expiration in the token doesn't really do anything. So we are going to write a simple logic that will check if that token has expired. It will return an error that this token has expired. So to do that, we are going to import from datetime. We will need datetime. We will need time zone. Yeah, we need time zone. So okay, check expiration. Now we are going to check that if datetime.now and time zone.utc is greater than this token expire time, right? It means that the token has expired. Like, for example, we create a token that is meant to expire tomorrow. All right. To know if this token has expired, we need to check the time that we are now, is it greater than the expiration of this token? If it is greater than the expiration of this token, it means that the token has expired. Right. I believe, do you understand that logic I'm trying to bring there?
Yes, I understand the logic.
Okay, so that's what we want to do here. To take the current time, we use datetime.now, and we want to use UTC time zone. Then we want to check if it is greater than token data expire. If it is, you should raise an exception with the status code of HTTP That is the HTTP. It should be for unauthorized. Then with the detail of your token has expired, please log in. So that's that. We have checked for the expiration at that stage. Now, if the code escape passes that stage, it means that the token is still valid. All right. So the next thing we are going to do is to extract the user from the database. So now our user will be able to let us import user from models. From models.users import user. So user is equal to await user.gets unknown. Then ID is equal to token.user ID. All right. Now, if user is none, raise an exception. This user does not exist. That if that user doesn't exist, that's if our query gives us none. We want to simply tell the client that the user does not exist. And if the code has escaped all those checks, it means that everything is right. All right. So we simply need to return the user. So, all right. So that's the end of our algorithm. It was very long. Please, do we have any question on this?
Okay, so if I understand, let's say the concept of this, because I try to like look at the like how does it apply in a practical situation. So it's like, I'm guessing this is like, let's say I go to a website, let's say maybe I log in on maybe, for example, I have Udemy account or something, I log in, and I notice there are like two scenarios. Yes, is let's say if I log in now on my account, there's some kind of registration or connection that goes on, whereby if I just open the Udemy website, the next time I open it, I don't need to log in again because it's already logged in. Even if I have another tab open, and let's say in the other tab, I was not logged in. If I refresh the page, because I've already logged in the first tab, the other tab will automatically connect to my account. I don't know if this is like the kind of, would I say, what we are trying to set up. So a kind of authentication whereby whenever you are going on the website, it checks, okay, is this person logged in or something like that? And we are setting expiry time. So I know that there are some sites where generally almost all sites, if you log in and maybe you do not use the site, you do not open the website again for maybe like 2 weeks or so. Next time when you try to open it, it will tell you to log in again. I don't know if it's that same kind of concept we're trying to.
Yeah. It's exactly the same thing. So, if we ask the user to log in every single time, like it will also cumbersome. Let's say I access the website now, then I close my browser, and in the next few minutes, if I want to access it again and want me to log in, it will be too cumbersome, right? It will be too cumbersome. So this is where these auto tokens come in, right? On that first login, we issue a token with an expiry time. Just give this token to the client, and the client will store it somewhere. For web apps, it can be stored in cookie storage, or maybe the browser storage. I've forgotten the name, but it will be stored on the browser. Then for each request that you want to make, like when you reload the whole thing, it will then check if this token is available there. And if it is available, it will attach this token to your request and send this request for you. So when this token is attached, it will be easier for, well, when this token is attached, it is now up to this particular function, get current user, to extract that token. Like we've extracted at 22, it will then decode the token, validate the token, check if everything's okay, it will execute the request that you wanted to execute. Now, if anything should be wrong with the token, let's say it's expired or anything, it will then return the error to the front end, and the client app will be responsible for maybe checking. If it has this particular error that the token has expired, it will redirect you to the login page to log in again so that it will have a new token. So this is just exactly how it works. All right, your explanation is perfect. That's how it works.
All right, sir. Yes.
Hello, sir. I have a question.
Okay, please.
Good afternoon.
Good afternoon.
Sorry, my background will be a little bit noisy, but my question is this particular error that we got when we ran the test that showed models.users.user cannot be logged.
Yeah.
I don't know what could have caused that error because I've run into that error before.
Okay.
Even when the database was correct, and it still gave that error.
Yeah, the error is quite strange to me, but I'm going to look at it. So I'll look at it after this class, so that by next class we will fix that before we move on to what we're supposed to do.
All right, sir. Because it's exactly the same error that I got, and I'm surprised that we got it.
Yeah. I'll look into that at the end of the class.
All right, thank you, sir.
Yeah. All right, so that is that. Now the next thing we are going to do is we need to actually test this if this actually works, in case you have an error. So this particular endpoint you are seeing here, so to actually make use of what we have constructed so far, we are going to import that get current user from library.dependencies. We are going to import get current user. Then we are going to just a minute. Okay, we are going to import security from FastAPI. Security from FastAPI. Then we will need to decorate our endpoint with what we created there. Our current user. As we want to capture the user making this request. The current user is equal to security get current user. Now, don't forget I said something about scopes earlier, but ignore this one now. I will explain this later. So what we want now is, this should be before, we should have, we should always have a positional argument before keyword argument. Okay, so what this does is that this security takes in the scopes, right? And then it takes in the function you want to execute, and it stores in the results at this current user. So what we want to do is you want to print the current user's username just to check if this works. Email, not username. Current user email. So we'll print that there and we'll see if it works. for this, I'm going to start the server again. And let's go to our client. Let's go to our client. Okay. So the problem we are having here is that this thing has refused to test. Okay, I cannot test here. Okay, it's working now. No. Okay, it's working now. It's working now. Let's remove this. So this is user/updates. Alright. It's a push. No, it's a push request, not push. So I want to check if it works, and so that we can get the chance to fix any error we have. Yeah. So can you see what we have here on the? Can you see what we have on the terminal?
Yes. Test
Yeah,
at
so we-
test.com.
Yeah. So our email is actually test.test.com. I see test.test.com. That means our algorithm here works. It first captures that token. This token we've attached to the header. So I see headers. Yeah, headers. You can say authorization, then bearer slash the token. Right. So our code then captures that token. Then it then checks if it then takes the user ID, takes the expire, then loads them all into the pedantic schema. And if these are known, it raises an exception. If there's validation error, it raises an exception. Then it checks the expiration. It checks the expiration, and it does a few other things. Like it then extracts the user from the database, and if this user is found, it returns this user to our code. That's why we are able to like access this user, this current user, and then we can do anything with the user, like get the email. So now let us try entering a fake. Let us enter a fake token and see what happens. This token is now fake. Yep. Can you see this? Your auth token is invalid, and it returns a 401 code as this is unauthorized. That means our code at this point is executed because, of course, the token is invalid, so it will raise a JWT error. Okay, I hope we all understand that. Is there any question on that?
Yes, it's clear.
Okay, it's okay. Now we are going to handle the updates. We don't have much time, so I'll rush this part so that we can complete the update and the delete as quickly as we can. I will come to the schemas, the users. Can you see this user update schema? What data do we want to update? Let me split my screen into two. Okay, what data do we want to update? Of course, we want a user should be able to update the first name and okay. Let me do it this way to save time. I will copy whatever we have here copy what we have here. So here. Then we are going to import typings from typings import optional from typing, not typings, import optional. Then from Pydantic, we should also import here. Okay. This first name too should be optional as well. Optional. And the default validation. All right, so with this, we are done with our user, the user update schema. So to actually make use of this, we are going to
stretching. I'm looking for stretching. Connect ligament connections. Only.
Okay, so the next thing we are going to do is to actually handle the update, right? So what we're going to do is we're going to run await user. Oops, we don't have a user, so we need to import it here. From models.users import user. So await user.get, and we want to get a user with an ID equal to our current user ID. Now, Fast API has an update method. Okay. Has an update method you can pass in. And with that, we can then pass in a dictionary that contains all the things that we want to update. In this case, that will be data.dict. Then, of course, we need to spread that data.dict, and we want to exclude the unset values. The values that have not been provided by the user should be excluded. So with this, we have completed our user update. Now we are going to return the same thing. We are going to return that. The updated user data, we are going to return it to the front end. Please, any question on this? Uche, Mike, any question on this? Okay, I believe no questions. Now to handle deletes, we are going to do the same thing.
Sorry, sir, no question.
Okay, sorry. So to actually delete a user account, we will do the same thing. We will decorate an endpoint that takes a delete request, and it will be async and async endpoints. It will be an async function with the name of delete. And we'll simply get a user with that ID and then call delete. Then nothing, that's all. So that's all for the update endpoint and delete endpoint. So please, do you have a question on this so far?
Okay, to refresh, like this one, this user is meant for what exactly? This is like the main endpoint where the main endpoint for updating and deleting from the database, right?
Yes. So this particular endpoint is meant to update a user account, right? So the user sends in the data he or she wants to update. Then we will get the user from the token Then we'll extract the user from the database and then update the credentials the user wants to. We update the data the user wants to update. Then we return the updated user to the client. And delete is the same thing. The user sends a delete request to this endpoint, and we simply get the user and call delete on it.
Okay. Okay.
Yeah, so let us test. Let's test this. See if it works. Okay, so it's okay with it. We will update the first name only. First name. I want it to be. Now let's send this request and see. The auto is invalid. Okay. I messed with my auto. Oh, we have to log in again. Sorry about that. Good. So that's a port / login. Method not allowed is a push request. Okay, so it's logged in and we now have a new token. Let us come here and paste the token. Okay. Now we'll go to user. Update. And I want to update only the first name. Once updated that, method not allowed. Okay, yeah, it will be a put request, not post. So let's see what happened. Internal server error. Oops. So let's see what the issue is. Okay, there's a mistake here. This should be exclude on set, not exclude. So we'll change that to exclude.
I even noticed it from the beginning. I forgot to mention it.
Yeah, thanks. That's exclude on set. So let us send the request again. Still another error. One validation error for user public response. Valid is not a valid date. Okay. Let's see what the problem is. Okay, we are trying to return user date, which is a coroutine object. We actually need to await any coroutine object we are working with. So let us run it again. All right. As you can see, my first name is now updated. Now, let me update last name as well. Let me change it to last. Good. As you can see, my last name is also updated. Now let us test the deletes. I want to delete my account. So let us test that. We'll send a delete request to user delete. Good. Status okay. The request is successful. So that is that for today's class. Do you have any questions so far? Okay.
Sorry, sir. I have a question on the
Okay.
delete endpoint. Like, what parameter does the delete endpoint take? It doesn't take any parameter.
Yeah, it doesn't. It doesn't. We don't need any parameter to delete. We just need an identifier of the user, which we can get from the token. Then when we have that, we simply extract the user with that particular ID and then delete the user. No parameters.
Okay. So that means while the user is logged in.
Yeah, yes, the user needs to log in to interact with any of these endpoints.
Okay.
Yeah.
I understand. Thank you.
Okay.
Okay, sir. Like I know we are trying to create a kind of like Twitter clone, something like this. That's the whole
Yeah.
app we are working on.
Yeah.
So, and based on the way we had it, we have a user class, and then a user can have likes, can have tweets, can have different. We have likes, we have tweets, we have I think picture, something like that. So this what we are deleting currently in this page now is it the user and everything that the user has, all the likes, all the pictures, everything that is related to that user. Is it what we are deleting?
Yes, if you look at our models, right? Take for example the tweets. You can see that we have that it's a foreign key field that is related to the user. That user we deleted. And if you look at our migrations, the first migration, you see something. Let me show you. Yeah, tweet. Can you see this on delete cascade? I think we explained this on that particular class. Yeah. What this means is that when that user is deleted, the tweets too should be deleted. Right? Anything, any relation to that user, any object that is related to that user, right? If you see tweet is on delete is cascade, comment is on delete cascade, like is on delete cascade, just everything is on delete cascade. So when that user is deleted, everything that the user created is deleted as well. But if you don't want that to be the case, you can set the on delete to be set null instead of cascade. In that case, if that user is deleted, take for example the tweets, this user will be set to null. But it will be set to just null, and we'll still have the tweets there.
Okay. Yeah. Okay, I get it now.
Okay, so that will be all for today's class. And in the next class, the first thing we're going to be to tackle that we had earlier. And when we're done with that, we are going to look at how to create tweets, update, and delete tweets. So for that, let me push this to the top so that you can follow me. So we push master.
All right, sir. Thank you very much. Really appreciate that.
Okay, it's all right. Thank you.
All right, man. Mikey, thank you. Thanks for that stuff, bro. The thing worked. We'll talk later now.
All right, thank you, sir. Thank you, Uche.
Oh, it's all right.
Thank you, sir.
Okay.
All right, sir.
Okay. So you can drop off the call, or I'll push the code later on.